Hello, my name is Chris Irwin and I am a global training instructor lead with MSA. I have more than 10 years of experience working with people in various industries within the fall protection trade. Today you're kind of joining us in a discussion of fall protection. If you were here with me in our 2-day class, we would discuss a lot of other issues such as when is fall protection required, all of the OSHA law, those kind of things. But today we're focusing in specifically on a really important subsection which is called the ABCs. That is basically if you're using a personal fall arrest system, all of the components that comprise that system. The A being the anchor point, typically we're talking about something like an I-beam. B being the body wear, such as all of the harnesses that I have behind me, and C, the connecting device, which is either a lanyard or a self-retracting device. So logically, we'll start with the first part of this, which is the anchor points, the letter A. The very first thing that we need to talk about when it comes to A is, what is this? The anchor is the thing that you're physically attaching your system to that's there to catch you at impact and then suspend you until we can get you down after that fall. A very important consideration, really the first consideration after we've found something that we think might work, is how strong is it? And really there's two possibilities when it comes to strength under the law. The first one, this is the one that's probably most commonly used and known, is 5,000 pounds. That's what we refer to as a non-certified anchor, meaning basically anybody who is fall protection trained can identify this. At a high level, what we typically teach people to look for is something that they believe could suspend their full-size truck if they were to hang it from it. This is not to say we actually do that test. It's more of a mental type exercise. But we're looking for something that could hold a 5,000-pound static load. The second possibility when it comes to anchor points is something that can hold twice the load that we'll actually put into it in a fall. So we call that safety factor of 2, and this is actually determined by what's known as a qualified person, and it's actually what's known as a certified anchor. So in this case, it's a specialized person that has a background in analyzing anchor points that has determined that the object that we're going to attach to, whether it's an I-beam, could be concrete, could even in some situations be wood, or maybe even other structures, they're determining that whatever we're hooking up to can hold our force at impact times 2. And again, that's what we refer to as a certified anchorage points. As an example for a certified anchor, what OSHA states is the anchor must sustain 2 times the load that we could put into it. Where do we get that number from? What number would they actually use? Usually for that, we look to our fall arrest gear, which has what's known as a maximum arrest force. So this energy absorbing lanyard by law cannot expose me to a force of more than 1,800 pounds. And if we think about that, I'll be feeling 1,800 pounds on me, but my anchor above me will also be feeling that same force. So typically for a certified anchor, what a qualified person, typically being an engineer, will do is they'll double that 1,800 pounds, 3,600 pounds, and that's what they'll certify. Some people look at that 3,600 pounds and they say, that's not as robust as a 5,000-pound anchor. I agree with that, but it does actually have documentation. It does have some kind of in-depth analysis determining that it's okay for use. I should mention that 3,600 pounds is not the only number that's used, but it's probably one of the more common numbers that an engineer will certify an anchorage point to. All right, we'll say that we've found our anchorage point that is going to meet either one of those 2 requirements, either certified or non-certified that we talked about previously. The next question is, how do we physically attach to it? And for our example today, we will say that we're using a full body harness, so imagine I'm actually wearing my harness, with this 6-foot energy absorbing lanyard. On here, the energy absorber pack, we always say, goes to your back D-ring, and the other end is the end that goes to the anchorage points. The question that we've gotten over the years is, how do I actually physically make this connection? For example, is it okay for me to wrap the lanyard around the anchorage point and connect it back on itself? This is what we refer to as choke loading, and we typically prohibit this practice for really a couple of reasons. Number one, the webbing is not designed to come into contact with an edge like that on this particular lanyard. And additionally, the snap hook, the hook here that has a gate that opens, this gate is not rated for that type of connection. So for those two reasons, we are not allowed to make a choke connection with our connecting device. In order to make that connection, we have different devices that are actually designed for this process. The first example of which is going to be what we refer to as a beam strap. This is a fairly, we'll say, basic type of technology that has some type of metal rings on the ends. Typically we call these D rings because if I turn it sideways it looks like a D. You might hear me refer to this as hardware. The metal might be galvanized steel, it could be stainless steel. In fact, it could even be aluminum once we get to some of the equipment we look at later. And then that's going to be attached to some type of a webbing, usually a polyester strap of some sort. In the past, we used to use a lot more nylon. And then there's going to be stitch points that unite the D-ring to the strap. So I have a couple D-rings, one big, one small on either side. And then we have a tag on here giving us some of the details for the strap. As we kind of go through the various elements, one of the common themes that's very important is understanding that there are proper and improper things that you can do with the equipment. In the case of the strap, it is important when I put it up here that the yellow piece be facing down. This is what we refer to as a softener. This is here to actually protect the red webbing on the outside. Now, for this particular strap, the way that I connect is I'm going to take the small D-ring and pass it through the big D-ring. And then here, it actually is okay for me to do a choke connection where I pass the D-ring through and it's hanging down like this. The reason why it's okay, number one, I don't have any opening parts here. And number two, it's actually designed and tested specifically for this. From here, you might say, well, what if I want to shorten it? Can I do that? And the answer is yes, I can take this if there is in fact enough strap to wrap it again and pass down through kind of like this. Just to give you kind of an image of what that'll look like with the entire system together. Again, we need to imagine I'm wearing my harness. We'll put the pack end to my back, and then the other end of my connector is going to go right here to the D-ring. So if you can imagine, we've got our A, which is the anchor point. The strap here is an anchor connector, and then I'm wearing my body wear, so full body harness, and then this energy absorbing lanyard is what we refer to as our connecting device. That's your ABCs. Now, beyond this strap, there are other options for different types of connectors. For example, something else that would work on this exact same beam would be something like this. I refer to this as a beam strap. This would be a beam clamp. So in this case, instead of wrapping the entire way around the beam, I've got these two jaws, or these two clamps, that slide in and out. Once I get on the flange of the beam, I'm going to push this side in and do the same thing on the other side. This will actually, in this case, loosely ride on the flange of the beam. And this is basically just another means of attaching. So I'll go ahead and put the one side up here. Go ahead and push that in. Same thing with the other side. I need to adjust and just basically make sure I've got a tight connection on here. Now here, this is actually designed to be loosely connected. So same thing, One end of my lanyard goes to my back D-ring, the other end goes here, and this is designed to be on here tight enough that if I fall, it holds the beam, but it's loose enough that I can slide as I need to move with this particular connection. You might wonder, why do we have two different possibilities when it comes to anchor connectors? We've actually got many more than that. It really comes down to what is correct for the job. Maybe if we're doing something like hot work, I don't want to use a web strap. I want something that'll be a little bit more robust, and maybe I need some mobility. For that reason, I could switch to this clamp. If you look at these two devices and think, you know what, I've got a different a job beyond this, there are many other varieties of connectors that are specifically made for all different types of anchorage points. Whether it's I-beams or wood or concrete, there's a variety of different connectors that are made for all those different situations. All right, now that we've talked about the A part of the ABCs, the next part is the body wear, and that would be your full body harness. And on this table, I've got an example of kind of our main harnesses here at MSA. I've got the kind of most economical that we offer, the V-Form over here, the top end V-Flex, and then the one I'll be inspecting and using today is called the V-Fit right here in the middle, the gray harness. Couple things that I'd like to say before I get into an inspection of this is that harnesses are not one size fits all. When you're buying a harness, you want to make sure you check out the sizing charts that are available for the different styles that are out there. Realize that sizing is going to be based on how tall are you and what's your weight. So you'll get a chance to look at that chart and pick from, for us, small, standard, extra large, and super extra large. So we're going to say that I've picked this harness for myself, and I'm now getting ready to go to work for the day. The very first thing that the law requires before I start is a pre-use inspection. I would like to just walk through what the various steps are to that inspection. You can inspect your harness different ways. You could hang it up from a chair. You can hang it off of the anchor point. Just to give you a nice visual, I'll go ahead and put it on the table here and walk you through the various points that I need to look at. I like to follow a pattern starting with the dorsal D-ring that I had mentioned previously, and then you'll see kind of where I go from here. The D-ring, once again, we had D-rings on the beam straps that we looked at previously. We're going to have another D-ring in this case. Once again, as I discussed, this could be made out of different types of metal. And again, from harness to harness, that can change a little bit. But my inspection points are always the same. Probably the most significant thing I'm looking for is there any corrosion? So we're looking for red rust specifically. I'm going to try to get in here the best that I can to inspect the entire area that I can see. On this harness, I actually have these tabs that I can turn, and that actually separates the back pad away from the harness, and I can physically actually get in and see the underside of that D-ring. And I always tell people, if you're working in a hot environment, very humid, or maybe it's been raining, that'll be the area where water is going to pool and probably stay present for longer. So that's actually one of the first places that I look to see if there's corrosion anywhere on the ring. Besides corrosion, we're looking for any kind of dings where the diameter of the D-ring is physically reduced. So if I see, for example, where metal's been rubbing on metal and there's kind of a divot in the metal surface, that would also be a reason for failure. Also, any sharp areas where it could cut webbing, that's also of concern. Maybe not as common, but still we should look for it, is any kind of cracks. And then the last thing I always mention when it comes to hardware is we're looking for any kind of bends that were not part of the design. In this case, I always like to point out the ring actually has a bend, but that's actually so that when I'm trying to reach behind and connect myself, this is not laying flat on the harness. It's a feature that makes it easier to connect myself. So you should know, is this a design of my harness, or has this harness been affected in some way by being used out in the environment where it's now got a crease or a bend in it. So hopefully you know whether or not this was actually part of the original design. From there are other features I need to look at. The next one that I typically go to is webbing. We'll actually go to this side here, since I've got a nice long piece of gray webbing that I can look at. I'm looking for any kind of things like cuts, tears, frays, burns. Anything where the webbing is not in the condition that it was when it was brand new is going to potentially take away from the strength of the entire system. Even an 1/8 inch cut, so just really this black area right here, if that had a little ding in it or a little bit of a cut into it, an 1/8 inch cut reduces the strength of that webbing in half. So if this were rated for 7,000 pounds when it's brand new, that 1/8 inch cut has now brought that down to 3,500 pounds. So we can't allow any kind of cuts, any kind of tears. An abrasion would be kind of a cut over the top of the webbing. And then burns would typically show up as like a hard, shiny spot. We typically tell people to flex the webbing and kind of pass their fingers over top. You'll feel it kind of as a hard, plasticky type feel if it's melted and cooled and it's still on your harness. And then obviously we don't want any holes or anything like that going through. Now, there are certain types of things that you might find that do not automatically cause failure. For example, is the harness dirty? We understand that you might be using this in dirt and grime. Mud and things like that are not a reason for failing the equipment. However, we do recommend that you keep things clean. Typically, the recommendation for washing your harness would be using a mild laundry detergent or a dish soap. I always tell people, use a sponge, kind of like you're washing your car, and wipe down the webbing, and then I would take just some clean water and a sponge again and wipe it off. There are things that we need to avoid doing, like using a pressure washer, using any highly powerful chemicals that are not rated for this, things of that nature. And when we're talking about the metal components, we're staying away from oiling anything. We don't want to be using gasoline or something to clean. All of those things could be damaging to the webbing. And then as it dries, we don't want to do speed drying. So no hair dryers. Really, you shouldn't even set it out in the sun because UV rays will degrade the webbing over time. So we always say let it drip dry in a cool, dry place out of direct sunlight. Speaking of sunlight, that also, as I mentioned, can fade the webbing. If you notice that, for example, I always like to go to the tag area here. If you notice that the color of the webbing that's been protected is different from the color that's been exposed to the sun, that UV degradation by itself is reason for failure of the equipment. Same as if I splashed a chemical on the webbing right here and it's noticeably changed colors and I cannot wash that out, that would also be perfect reason for failure. Tied to the webbing, I briefly should mention, right here at the back pad, there's two areas, one on this side and one on this side, where the webbing has been physically folded over on itself, and there's a straight stitch going through. This is an example of what we refer to as a load indicator. In the case of a fall, that stitch will rip out, the webbing will straighten out, and as an inspector, if nobody has told you that this equipment has been used in a fall, that's your first sign. If that webbing is straightened out and typically there's a tag underneath, that's your first sign that this equipment has been loaded and should not be used for fall protection moving forward. So beyond webbing, next thing we'll look at is the tags. I really like this harness because it does tell me the size before I even start working with this, so I know I've got one that'll fit me. This one here I've got is the standard. As for the tag, what am I looking at? I'm going to really at a high level check to make sure the tag is present, so none of these have been ripped out and are missing, and legible. Can I read every word on all the pages that are in here? There is important information that I can get into in here, such as what's the product number or the model number if I want to replace this with a new harness for myself. There's also information on just what the materials are that make everything up, whether it's the hardware, the webbing, so on. There is a manufacturer date. I often get asked, is there any lifespan for this equipment? And whereas in the past we would have said yes, typically there was a 5-year lifespan, that's gone away. Now, as long as your harness and other equipment, for that matter, passes your visual inspection, then you can use it indefinitely. But it does have a manufacturer date, and it also has a serial number, which is unique to this equipment. So that really helps during the process of your inspections. I mentioned that right now I'm doing a daily inspection. This is done by the user. Typically we call that the authorized person. You also are likely to have at your job site what's called a competent person inspection. That person is somebody other than the regular user that would pull this equipment out of the field either once a year for industry or twice a year for construction. And then, like I said, just do the exact same inspection, but it's documented. That's where I would basically pull up this information off the tag, put it into my database, and just show the results of my inspections so that I can show that, hey, somebody different has looked at the equipment, and I can show how many years we've actually been doing this. So those are all tag-related items. Go ahead and close that back up. The last kind of different area that I need to get into is going to be stitch points. And this harness has a bunch of different stitch points that you can see all over different parts. This is where we're uniting ends of the strap together. Here we call this a honeycomb box stitch. You've got kind of the box pattern on the outside with a honeycomb type style on the inside. Things I'm looking for here, I want to make sure there's no broken stitches. There are no areas where the webbing is actually physically pulling apart, and I can see kind of the threads that's holding everything together. And then the other very common question I get is, what about this? What about this thread right here that's sticking out? Is that acceptable? This is actually the end of the stitch. These are all done on a sewing machine, and when they're done, they cut it free. We call this the tail. As long as when I pull on that, the webbing or the stitch does not, or the stitch point doesn't start to come undone, then that's perfectly fine. On the other hand, if I were to pull on that and I could see the stitch unraveling, that would be reason for failure. The final thing that I typically talk about at a high level on inspection is your buckles. Now technically these are a type of hardware just like the D-ring, but they do function a little bit differently. So the one that I'm looking at right here is what's called a tongue and grommet style buckle. It's kind of like the belt that you would wear around your waist. But here, I'm just going to kind of check for functionality first off. And then I'm looking for very similar things to what I did here. Is there corrosion? Are there cracks? Are there any bends, anything like that? I'm going to check this roller to make sure it spins and making sure the tongue is not bent. But the other thing I always mention here is you're not allowed to make any permanent modifications to the equipment. The most common one here is this grommet, that's what these are called, is too loose. This one's too tight. I'll poke a hole right here in the middle. That is not allowed. You don't want to do anything to your harness that you cannot undo. All right, so that's one style buckle, and this harness actually happens to have a different style. On the front, these are what I refer to as a quick connect buckle, kind of like what you have with the seatbelt in your car. You push them together, they lock. I can check that. And then physically here, I've got these two little tabs, one on either side, that have springs underneath. I'm going to check to make sure those springs are functional. And Besides that, I'm just checking to make sure it slides and locks as it should. Once again, I just want to repeat, I'm not allowed to do any oiling or anything like that. Let's say it's getting corroded. Really the maximum that I can do is use that sponge with a dish soap or a laundry detergent, and that's all the farther I can go. If there is damage, I can't fix it. That's really the end for this piece of equipment. From there, I would basically be looking at very similar things to finish my inspection. As I mentioned at the beginning, I like to follow a pattern, so I would have worked my way down one side. I would do exactly the same thing, looking at all these points that I discussed on the other. Then I would work my way over the top and then down the front side of the harness, looking at all those points. There are different points that are unique for all the harnesses that exist. Make sure whatever you're inspecting, you're reading the manual and you know the specific inspection points for the equipment that you are specifically working with. All right, the final portion to the ABCs is the connecting device. We've already looked at anchor points and their connectors. We've looked at body oar, which is your full body harness. And now in the category of connecting devices, we really have two broad categories. On my left, I've got what we refer to as energy absorbing lanyards. And on my right, we have some examples that fall into the category of what we refer to as a self-retracting device. These small devices we refer to as personal fall limiters, PFLs. So starting with the older technology, let's discuss the lanyards first, and then we will discuss the self-retracting devices, or SRDs, that I have here. As an example of a lanyard, this is a good one, and typically we have something that looks kind of like this, where it's a 6-foot long device from end to end. So if I were to measure from here to here, 6 feet, notice this is adjustable. There is a buckle on there. If I wanted to push some webbing through and shorten the length, I could. But we'll work with the full length here. Energy absorbing lanyards, as I mentioned, have been around since really the probably early 90s and still very common today, really because people are very familiar with them, and also from a cost-effective standpoint, I would say they're probably your more economical device. So as I mentioned previously, these do have various components on them that I'd like to just kind of briefly walk through and discuss what they're called and some requirements that must be met. This is what we refer to as the snap hook. This is actually a 3/4 inch opening hook, which basically means how far does this thing open from here to the gate. As you can see, the gate is spring loaded, so it's auto close, but it's also auto lock. I have to press in 2 locations, here and on the gate at the same time, for it to physically open. And then when I let go, as you can see, it auto closes and it auto locks. There also is something else with the gate I'd like to briefly mention, and that is the strength. This is an ANSI compliant gate. ANSI is the American National Standards Institute. ANSI dictates that this gate be rated to at least 3,600 pounds and so marked. That 3,600 pounds should ring a bell. We talked about a safety factor of 2 with a certified anchorage point. This is the exact same number that was being talked about previously. All right, so we'll see that marking on there, and that'll be true whether it's a small hook like this, could be a large, what we refer to as rebar hook, which we'll get into here in a little bit. And these could also change metal types, galvanized, stainless steel, and even aluminum. They're going to have those characteristics that I just talked about, even if they look slightly different. From there, we will see a length of webbing. So we've got, again, polyester webbing. It's more narrow than what we saw with the harness, but same material. Also another stitch point on here. Keep in mind, from a inspection standpoint, really a lot of the things I'm looking for are exactly the same. is what we talked about previously with the harness. So probably the one thing that would be unique here is I'd want to make sure operationally it's auto close, auto lock. That hasn't been defeated. Corrosion hasn't made it so the gate hangs up, those kind of things. All right. Working to the other end, I've actually got another snap hook. Remember, this is the end that goes to my back D-ring. But right prior to that, I've got what we refer to as the energy absorber. And this is usually where we have kind of a number of items to talk about. And really it all comes down to the information that's contained on this tag. For example, one of the things I did not mention with harnesses, but we can mention here, is capacity. Every piece of equipment, whether it's a harness or even the beam strap or the beam clamp that we looked at previously, they're all going to have a user capacity. That is how heavy can you plus your tools be when you're using this equipment. Most lanyards, I say most because there's always exceptions, but most lanyards are rated to from 130 to 310 pounds, meaning there's a top end number and there's a bottom for how heavy you can be when you're using this equipment. The next number I'd like to point out when we're discussing this is the average arresting force. I mentioned previously that the maximum arrest force in a fall by law is 1,800 pounds. However, most of this equipment will not take you to the limit. It will subject you to, we'll say, a slightly softer force. And one of the more common numbers that you'll see is an average arrest force, meaning it's some force is a little higher, some force is a little bit less. But on average, in a 6-foot fall, this thing is going to subject you to about 900 pounds of force. The two numbers that are very important for me that we spend a lot of time on are this big 6 here, and then there's a much smaller 48 inches that we can see down here. So let's talk about this first. This 6 tells me the maximum free fall permitted with this lanyard is 6 feet. Free fall is the first part of the fall. So imagine again, this is the anchor, and this end is coming up to me. Free fall is that first part of the fall where I'm falling. Okay, so I'll just do that in real time until I get to the end of the lanyard and this thing starts to deploy, this thing starts to operate. Well, the important thing to keep in mind is depending on where your anchor point is, whether it's above you or potentially lower down, that actually affects free fall. With this lanyard that has a white label on it, it is critical, very critical, that I attach at shoulder height or higher. If I start to attach lower than that, my potential free fall could be more than 6 feet, with a 6-foot lanyard, I should say. So that's very important to know with an ANSI white label lanyard, which is what we would refer to this as. My anchor point must be at shoulder height or above me. Anything below shoulder height would not be acceptable with this device. The other number that I would like to point out is, again, that small 48 inches down here, and that refers to the maximum deployment distance. That's your brake. This is your energy absorber, whatever you want to call it. When you hit the end of the lanyard and it starts to slow you down, it starts to dissipate that energy, this is what's going to slow you down and stop you. I've actually got an energy absorber here that's been through what we call a drop test. Prior to the fall, this is all wound up neatly in this package. However, at impact, when I get to the bottom of that free fall, one hook is pulling this way, the other hook is pulling this way, and then this white material on the inside is what we refer to as tear tape. It's an interwoven material that rips right down the middle. You can see I've actually got some untorn tear tape right here at the end. It takes about 900 pounds of force to rip that tape. That's where your average arrest force actually comes from. So imagine this pack here opening up. That 48 inches tells me that at a maximum, the amount of brake that you have, the maximum, I call it deceleration distance that you'll ever have is 4 feet, 48 inches. So think about that combined. I can actually, this is not exact, but this will give you an idea. Your lanyard starts out as a 6-foot device, and by the time you're done, it's going to tear open on the end here, and we're talking about a 10-foot long device by the time all is said and done. That is important to know from a fall clearance standpoint. Another major part of our class typically is to talk about how much room do you need to have to not hit the ground. So with this particular lanyard, you're going to need to account for those particular numbers that I talked about. Now, the alternative to a white label lanyard is what we refer to as a black label lanyard. Instead of having a white label like this, it's going to be all black with white numbering and lettering on there. Things that change if we go to that particular style. The most significant thing is going to be the maximum free fall. Instead of having a 6 right here, it'll have a 12. That basically tells you that any anchor is okay, whether you want to attach overhead, shoulder height, or even at foot level. If it has a 12 right here, that basically indicates that's okay. The other things that change, the force does go slightly higher. This 900 goes from from the current number to 1350, 1,350 pounds. And the other thing that's really important in my book is the deployment distance goes from 48 inches to 60. So it adds 1 more foot of deceleration or deployment distance to the very end. But I personally am a big fan of the black label lanyard. It eliminates some of the room for error that you might have with a white label, where I talked about the limitations. Yes, you do have an extra foot of deployment that you have to consider. Again, though, my opinion is I like that black label because it does give me some more freedom for where I can attach. All right. Now, on this table, I do have a kind of a variety of what we refer to as specialty lanyards. And really, hopefully, we're making this simple enough that you can look at the label and you can kind of get an idea of what this thing is actually designed for. So this one right here is a stretchable lanyard. I might call it bungee. When I pull on those legs, they kind of stretch out. That's just basically to collapse the leg when you're not using it, but when you need it, it straightens out. That's what this pictogram is meant to tell us. This would be for arc flash. If you're an electrician doing something of that nature, if you see that particular symbol, you know this is designed as your arc flash lanyard. You would have an arc flash harness and perhaps other gear to go with it. This one right here would be a hot work welding mask. So anything that's hot work, welding, grinding, spark producing, flame producing type things. This is what we call a tieback lanyard or a choke loadable lanyard. So I said previously it's not okay to wrap my lanyard around the anchor point and connect back on itself. This is the exception to the rule. It's designed with webbing that's okay for that, and also a special hook that's designed for choke loading. So lanyards are one end of the spectrum when it comes to our connecting devices. The other end of the spectrum, and I would say the newer technology, would be your self-retracting devices, SRDs. They go by many names, by the way. I've heard them referred to as retractables. Many people call them yo-yos. You might hear them referred to as SRLs, self-retracting lifelines. We're talking about the same thing. Some small differences in use, but those are all really the same item. I'm going to use this VTech personal fall limiter. Personal means it's something that I actually can wear on my harness and carry around with me. I'm going to use this to kind of discuss how these operate and why a lot of industry is actually starting to move away from lanyards and go to these. I'm just going to use my lanyard one more time as to help me make this example. So in the case of a lanyard, you do go quite a ways before it starts to catch you. If I use the exact same person, exact same anchor point let's say this goes to the same anchor, this goes to me, what I like to show people is the stopping distance is much faster. So a lot of companies are going away from these in favor of these, really because of the favorability when it comes to fall clearance, which we can talk about. But backing up just a little bit, the category name is self-retracting device, SRD. This particular device has approximately 6 feet of webbing. That can change depending on model. But it has about 6 feet of webbing contained inside. So it is actually a similar length to what that lanyard was previously. But it's called a self-retracting device because whatever length of line you're not using automatically gets retracted up into this housing. And that's what helps us when it comes to our fall clearance. We don't have as much line extracted in all cases, and as a result, that could benefit us if we were to take a fall in any particular moments. So on top of this device, we have what's referred to as a carabiner instead of a snap hook. So here, this is a triple action carabiner. I must press up, then turn, then push. Again, it's auto close, auto lock. I do have on here, I should have a marking that tells me that the gate is rated to 3,600 pounds. Then this part here is referred to as the housing. This is where all the webbing is located inside. There's actually a drum that the webbing winds around. I really kind of like this device because I can see internally that drum spinning, and if I look in the right locations, I can actually see that webbing going up inside. But the way this works is normally the line is free to be extracted or retracted. But if this sees a quick motion, if I give it a quick tug, there are these little pointy objects inside that are called brake pawls. Those actually flip out and lock, causing it to catch. So I'll go ahead and give it a quick tug here. So instead of pulling it all the way, let's just say I were to fall, that locking mechanism on the inside engages, and then that's where the fall begins to stop. Now, just like the lanyard had those two phases, the first one being the free fall, here I would typically call that activation distance. How far do you go before it locks? And then you technically do have deceleration. This is an energy absorber, just like we saw with the lanyard. Keep in mind, some devices actually contain the energy absorber on the inside, where you cannot see it, or in this case, it might be external. But you're always going to have some kind of braking after it locks, and that's obviously something I can't demo here. But after I lock it off like this thing will start to open, just like that tear tape we talked about previously. Now, the same applies here is applied to lanyards. There are specialty devices that are designed for different situations. I mentioned with lanyards, the two broad categories were white label and black label. And as of 2023, we're actually seeing that same scheme come into play for self-retracting devices. We have white label and we have black label. This actually is a class 1 white label. What that means, same as it did for lanyards, is I'm actually physically allowed to attach only to points that are at shoulder level or higher. I've got to keep my, we'll call it free fall down before this thing starts to catch. This would not be permitted, since it's white label, for me to tie off below my shoulders. So we've got white label here, and then we will talk momentarily here about the black label version of these devices. Other things about this, just before I move on, realize when it comes to specialty devices that a lot of interest is going to be generated based on what type of work are you doing. This is nice and small and lightweight for somebody who does not need tie off below their shoulder. So if that's your job and you're not concerned about those hazards, then this might actually be the device that you're interested in. All right, but as mentioned, there are other devices that I can use. This we'll start here. This is probably the other device that I really go over that's going to have a lot of popularity. Notice that instead of a single leg, this has two. So there's actually two of these devices. You actually can get a twin leg version of this style as well. It's just what I have here today. You can see that I've got the single with this and the twin leg with this. If I were to open this up, the tag is hidden inside. That's one of the nice improvements that I've seen them make in the last few years with these, is protecting this tag so that it's not going to get worn off or torn off. But if I go ahead and kind of flip into this a little bit, right here is that black label that I'm talking about. All right, this indicates to me that this thing actually is designed for tie off anywhere I like. Could be overhead, could be shoulder height, or it could be foot level. There's something else that makes this very unique as opposed to this device that we just looked at previously. Because it is designed as a black label device, we know that there's the potential that if somebody were to fall, their line could come into contact with an edge. Let me see if I can demonstrate this. So the potential exists in a fall that my line could come into contact with the edge of an I-beam, with the edge of a metal roof, concrete, you name it. There's a lot of different things. The typical line of the device I showed you previously, the Class 1, or even lanyards, in most cases, is not designed for a sharp bend like this. And unfortunately, there have been cases in what we refer to as leading edge falls where the line caught like this and snapped, and unfortunately the device is not able to function properly. With a leading edge device, which is what this is designed really a little bit differently. Number one, the webbing is much more robust. This is going to be a lot stronger than typical webbing. And then in this thing that kind of looks like a pad or a backpack type device, there's an energy absorber. So when that line comes into contact with that very sharp edge, the line is protected because of its strength, but also because the energy absorber that's in this pack, it's more tear tape, is going to rip out and lessen the force that's going to that particular point. The other thing I'd like to just quickly point out is when it comes to your self-retracting devices, one of the things that MSA is doing is color coding. I kind of like this. You can see, especially with these two devices, they're kind of the same family. If you see a gray device for us, that's going to indicate, before you even really get into the tags, that it's a Class 1 device, meaning shoulder height tie-off or higher. And then if I see a green device, think of green light, that's going to indicate that I'm allowed to tie off really at any of those locations, above me, shoulder height, or below me. And then the other thing is this nice pictogram right here. So you've got kind of an edge type shape, a 90-degree edge type shape, and then you can see the black line going over the edge. That is going to be our symbol to you. It's going to let you know that this is actually rated for leading edge. This is just kind of a broad overview of some self-retracting devices. We also make much larger ones that are referred to as self-retracting lifelines, where they're designed, again, for unique environments. There's one that has a rescue winch built into it called an SRL-R. There's also one for dirty environments called a sealed self-retracting lifeline. They all have a much bigger housing that goes with them. But they all work on really the same principles as what I've talked about here. My final comments on these, number one, fall clearance. Something that is very nice that they're doing, if I open this up one more time, is instead of having to add numbers and figure out things like we did with the lanyards, nowadays there's actually a nice chart in here. And yes, there is a little bit that I would need to teach you in order to read this chart, but it will tell you based on where you're working in relation to your anchor point. Let's say this person moves 4 feet to the side. and he's tied off at ground level. This is going to tell me on the tag exactly how much fall clearance I need. So they're actually doing a very nice job where I don't have to add anything. I can just look at a chart built onto the label to figure out my fall clearance. And then finally, when it comes to inspection, we talked about that with harnesses, we talked about that with lanyards. With these, inspections very similar. I've got more metal components, more hardware. I've got the housing. This is unique to self-retracting devices. I'm going to check to make sure there's no cracks or anything that go all the way through. I do have labels that need to be present and legible. I do have a hook on this end, just like we had on the lanyard, that I need to check for operation. And then the only thing that's really kind of unique here is I'm going to pull all that line out, and I need to do my visual inspection the same way I did with my lanyard. I'll let it retract. I'm checking for cuts, tears, frays, burns, discoloration, all those things that we talked about previously. I'm also checking to make sure does it fully retract. And then as I've demonstrated a couple times, I'm going to check it to make sure it locks off as it's supposed to. Regardless of what device I'm talking about, whether it's a harness, a lanyard, or a self-retracting device, if it has any of those kinds of damage, none of these products can be repaired. This is something that if you find damage, corrosion, cuts, whatever, we typically recommend take it out of service, red tag it so that people know not to use it, or destroy it so it cannot be used. So that gives you a nice idea of the different types of connecting devices that are available. Hopefully you can see from this whether we start with the older technology, the energy absorbing lanyards, or we're talking about the newer devices in the self-retracting devices. There really are a lot of different types of equipment to use depending on the job that you're doing. And that's where talking to somebody who is trained as a competent person, maybe you've got that person within your company, or your local sales rep, they can help guide you to what is the right piece of equipment for the job that you're doing. Really does make a big difference having the right equipment for your particular job, not only from a comfort standpoint, but also from a safety standpoint. I want to make sure that if I fall, the device that I have will be able to take that fall force and really whatever I put it through.